if I have 3 and 2/10 times 2 and 1/10, if I rewrote this problem as a fraction multiplication expression, just like we did yesterday, 3 and 2/10 could be the same as 32/10. The engaged way, making it a little bit more difficult than it needs to be. We know this. But of course it's going to lead it into the way that I was taught, the way that we kind of taught you at the end of first quarter. But this is just another way to do it. David. 2 and 1/10. 21/10. So now looking at the smoosh math, smoosh it together. 32 times 21. I'm not about to do that in my head. 32 times 21. 1 times 2. 1 times 3. Add a row, add a 0. Because I'm not multiplying it by 2, I'm multiplying it by 20.
Oh.
That's why we add that extra 0 on the second row. Because it's by a 10. That's why we add that extra 0. 2 times 2, 4. 2 times 3, 6. Add them. That's 2. That's 7. That's 6. So on my top, it's 672. 10 times 10, 100. So it's 672 hundredths. Yes, I know that that's improper. It's ridiculously improper. Yeah.
No?
I'm fighting not to do what I really want to do with that. But with improper, then you just divide the denominator into your numerator. Well, I'm dividing this by 100, so all you have to do when you divide by a power of 10, take that decimal that's right here, move it in 2 places. 6 and 7,200. So I'm going to lead into, with the same problem, lead into how we really work these problems. And I'm even going to say that the way that they want us to do it, I hate it. I really don't like it, because to me it's like this because they're using words, but I don't care for it because it's much too much for Rusty Crusty Dusty up here. I don't like it because for me it's like, just move the darn decimal. So, because they're using words. So what they're doing is right here, they've got 32 tenths. It's this in word form. We really don't solve it this way. Ever. It's just, to me, it's making it harder than it needs to be. And really, work smarter, not harder. I'm going to show it to you because you're going to see it, but not a fan. Okay? It's going to be on your problem set. You're going to see it on your homework, but I personally don't care for it. I'm going to show you the way that I really want you to solve it because I showed it to you first quarter. Okay, but I'm just going to show it to you because you're going to see it. So they've got 32 tenths times 21 tenths. I mean, I get it, I just don't like it. This goes with this. It's the word form of the fractions. It's just, why? Why? So, you would multiply it like we did right here, and you would end up with 672, like I did right here. I don't want to do all the work again, I just did it. And then tenths and tenths, you get hundredths. Because this to me is not practical. Because you're really not going to be a grown-up doing it like this. You're going to, the grown-up way is the old school way that we do it. You're really not going to be working it this way. So then when you have 672 hundredths, I don't like it. I'm going to say it again. I don't like it. Or as Reagan used to say when she was 3, I can't like it. I don't like it. So, can't like it. So, what I would really most likely tell you to do, even though it'll say it one way, because you got a couple of you are like looking at me like, I don't know, like you smelled something funky. So, what I would really tell you to do, if you like the fraction way of solving it, awesome. Do it that way if you like it. Great, do it. If you're sorry, prove it. But if you really like the real way that I'm going to show you to do it, because that's really the way that your future teachers are going to expect you to do it. Even better. Because it's how I showed you in first quarter. And you're like, why are you showing us this way when you already showed us this other way? Because. So, with the 32, 3 and 2 tenths times 2 and 1 tenth. This should look very familiar. I'm even putting that down over there. This has 1 behind the decimal. This has 1 number behind the decimal. Yeah. Then just multiply it. 1 times 2 is 2. 1 times 3 is 3. This is, you've got to know how to multiply though. Add a row, add a 0. This should be ringing a bell. There should be bells going off like, oh my God, you taught me this. 2 times 2 is 4. 2 times 3 is 6. Add it. Then you go, oh, I need to throw my decimals in there. You have to get all of them. If there are decimals in there, you have to throw them in your answer, because this isn't really 672. Because you've got really a 3 and a 2. It's 3 times 2. Really, it's 3 times 2. So your answer should be somewhere around 6. It's 3 times 2. So your answer should be somewhere around 6. You've got 1 behind the decimal and 1 behind the decimal, so my decimal needs to move 2 times. So it starts here in the back. Oh! So it starts in the back and goes 1, 2. So my answer really is 6 and 72 hundredths. Sound familiar?
Yes.
Okay, I should be ringing that bell. Ding, 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 ding. We have a winner, chicken dinner. This should be familiar. This is the way your parents learned it. This is the way I learned it. This is how we learn to multiply decimals. Not making it into a fraction. Not writing it out like words onto the side. This is how we multiply decimals. This is probably how your calculator does it. So, it's the most practical way. So, but if you like turning it into fractions, fine, do it. If you don't, fine, don't. But the making the fractions is just showing you why this is what it is. So, what we're going to do, I should say so. What we're going to do is we're going to look at the problem set, because there's a whole bunch of stuff on that problem set that's going to look really confusing. And if we have to, we might make some little notes on the problem set so that when I give you your homework, your parents might not be going, what on earth is this? So you can say, look, she doesn't want me to do it this way, she wants me to do it this way. Because I don't like the word form. It's silly. I don't like the word form. It's silly. There, I've recorded it. I don't like the word form. It's silly. I actually like you to do it this way. If you want to do the fractions form, awesome. As long as you get the right answer, I don't care how you get it. Just don't use calculator. Show your work. It's just, you know. Let's look at this together. So it says, multiply using both fraction form and unit form. Unit form just means, just use the standard algorithm. And so when they're saying the unit form, that means like 23/10. I don't like it. I hate it. So they're just saying, write it without the decimal in it. So I want to kind of tweak that just a little bit. I'm going to show you what I mean. Okay? Just wait a minute. Okay. So then it says, check your answer by counting the decimal places. The first one is done for you. So I'm going to show you how I want you to do it. So before you start arguing with me and interrupting me, just let me show you what I mean. Okay, because I don't like doing it with a unit form. I don't like it. Okay, guys. So with the fraction form, I really don't think it's that bad. It's not my favorite method, but it's not that bad. It's just showing you another way to solve it. So, over here on B, 2 and 3/10. How would that be written in fraction form? I don't know why I called you. You had food in your mouth. 23/10. So 23/10. How would we write the second part? 9/10. So then all we have to do a little smoosh, just so that it's easier to look at. And then multiply 23 times 9. I'm just going to do that little bit of math off to the side. 9 times 3. 9 times 2. 18 plus 2. 20. So my numerator is going to be, is not 207. My denominator, 100. 100 times 100. 10 times 10. 100. So if I had 207 over 100, what would my final answer look like?
2 and 7.
2,700. Because I have this number, my decimal comes in 2 spots. Now, yeah, this, but actually, really, if I look at it, this isn't really
Hard.
that, I don't want to say that hard. I don't want to say that it's a whole lot more work, because when I have multiplication like this, where it's double step, it's not that much more work. It's just a different type of multiplication. So it's just different. And sometimes different is like cooties. You don't want to touch it, you don't want to do it. So this is not my favorite, only because it's different from the way I was taught. It's just different. It's not my favorite. So this is one way to solve. This is one method. So when I'm over here, I do not, my personal preference, I don't like it. And I said it again, I'm going to say it again. I don't like it. So what I want you to do is I actually want you to cross out the words. Please don't do that. I think it's too confusing. Please cross those out. I don't want you to do it. I do want you to leave the numbers, obviously. And I want you to put those decimals back in there. I want you to practice multiplying with those decimals.
I don't like it.
They took the decimals out, and that's what they were doing. They took the decimals out and were saying it was like 23 tenths, 9 tenths. Just like over here, they were taking the decimals out and turning them into a fraction. They were saying that there were 23 tenths as the place value. If they put it on a place value chart, there were 23 in the tenths spot. 2 and 3 tenths is 23 tenths. So I just want to write it as a decimal so that I can look at that as a problem. If I wrote it, I would write it as 2 and 3 tenths times 9 tenths. So what I want you to do is I want you to start practicing actually writing it as multiplication with a decimal. So you can practice recognizing, okay, there's 1 here, there's 1 here. So I need to move in my decimal. How many spots on my final answer? 2. So one thing that I was telling my students before, there's 1 here, there's 1 here, and I would tell some people, write a little 2 up there in the circle so you don't have to, but some people you might need to. Remind yourself that, okay, I need to do this. Decimal needs to go 2 spots at the end. You don't have to, but some people you might need to. Then just go ahead and multiply it. 9 times 3 is 27. 9 times 2 is 18. Plus 2 is 20. Oh, look, my decimal needs to go 2 places. 1, 2, bam. Because some people were only doing their decimal from the top and forgetting the one on the bottom. They would go, oh, 1 decimal, whoosh, and totally forgetting the second one. So if there's a decimal on the second number, you have to do that one too. You don't.
So 0.
What? Like they would only move their decimal in 1 place instead of twice, because they were only looking at the top number instead of looking at the top and the bottom. Does that make sense at all? Okay, I don't know why you're saying 0. Yes, ma'am.
No, but if you like really big numbers and like with a lot of zeros, the number has 2 decimals.
No, you'll still only have 1 decimal. Because like I could have $1 million and 50 cents.
That one is great.
So it doesn't matter how big the number is, you still only have 1 decimal.
Oh, that's so strange.
That decimal, there's only 1.
Like, put a 0 behind them.
No. Because you have all of these numbers that are over here, your ones, your tens, your hundreds, your thousands, your 10,000, 100,000, your million, your 10 million, your 100 million, your billion, your 10 billion, your 100 billion, all of those over here. Then you've got your decimal, and then everything that's behind that decimal, but you've only got one decimal.
Okay, are you teaching any concepts?
So, but that is a good question. I mean, you can have more than one comma, but you can only have one decimal. So these are like your whole numbers, and then these are your fraction of a number. Yes, we can have the computer. Well, hello there. On this bottom part down here, where they don't really have anything written. So you have 6 and 6/10 times 2 and 8/10. What I would really want you to do is don't let all this word stuff mess you up, where it's got all the words. I would really want you to practice the fraction form. So it would be 66/10 times 28/10. Just pluck out the decimal. Dawson. The 6 is over the 10th place. London. Sit down. Then pick up a pencil. Pluck out the decimal. And put the number over it. And then you would need to multiply 66 times 28. 8 times 6 is 48. 8 times 6 is 48 again. Plus 4 is 52. That's 12. So that would be 13. 8 plus 0 is 8. 2 plus 2 is 4. That's 8. So you should have 1,848. Over 100. So when you take that decimal and you move it in 2 places, it should be 18 and 48 hundredths. Is that what you got? Awesome. And so, because I took up so much room, I didn't work down, I worked to the right. I didn't give myself enough room to do this. But it's still the same thing. So what I would do, I'm going to end up writing underneath this problem, but it's 66 times 28. Now see, when they were doing the tenths times the tenths, I would really just leave the decimal in there instead of writing the words. And I would make myself a little note. Me personally, I don't leave a note, but I'm telling some of you, go, okay, here's one, here's another one, so my decimal needs to move to the left 2 places. Am I? So here's one, here's another one, so your decimal needs to move to the left 2. Nice. And so we already know that after I multiplied it over here that it's 1,848. So your decimal needs to go 1, 2 places in. If they want to come in, they can knock and come in. So I want you to do letter D. Go ahead and try letter D.
I'm 11.
You're missing the point.
Everybody in this room said me.
Please listen to the dating circles of your children in 5th grade. They're talking about who's dating whom. Okay, so 3 and 3/10 times 1 and 4/10. We have better things to be discussing that are math related. Thank you. So it's 33/10 times 14/10 because you were supposed to also do it in Fraction form? Oh, yeah. Times 14. 12, that's 13. Add a row, add a 0. That's 3. That's also 3. 2, 9, 4. 492 over 100, which would give you 4 and 92. Oh my God! I multiplied. I'm sorry. You know, I was checking to see if you were paying attention.
That's what I did too.
Oh, sure you were. Sure you were. Sure you were. You sure
Right.
You can't prove a thing.
I multiplied.
Well, it's on the video.
But you know what? I can always delete this one and post the other one. Okay. So, 3 and 3/10 times 1 and 4/10. There's multiplication in my head. Sorry. Oh, you guys mess up all the time. So.
I did the same.
So, my decimal has to move in. I didn't say it was you. So, this is 12. This is 13. Add a row at the same. Add a row at a 0. This is 3. This is 3. 2. 6. This is 4. Decimal has to move in 2 places. 1, 2, 4, and 6,200. My mistake. I was adding in that one problem. I multiplied.
I got it.
It happens. Okay. But you can see where it will make your answer wrong in that one aspect.
Yep.
Okay. So these are done in the same manner, but all they did was add a little extra number in the back. So here it's 2 and 38/100ths. So if you were writing it as a fraction, 237 hundredths. I was trying to say it and I messed myself up. 237 hundredths times 9/10. You just pluck out the decimal and put it over whatever place value it is. Then smoosh math, multiply it. Now this again, don't worry about the words. Put the decimals back in there. Don't let that 0 mess you up. You don't have to multiply that 0. It's just there showing you that there are no 1s. That 0 is not important, Dawson. Right. They put it in there, but you don't have to multiply it. That 0 is just showing you that there are no 1s. This 0 right here, you don't have to do anything with it. There are no 1s. The only time you have to do something with the 0 is if it were that. Would you have to do something with it? There's a difference between this and that. There's a difference. Do you see the difference?
Yes.
Okay. This is tenths. This is hundredths. There's a difference. So on this, how many places will you have to move in your decimal? 3. Because you've got 2 here and 1 here. Moving your decimal 3 places in your final answer. So this would be 63. This is 27. Plus 3 is 33. This is 18. Plus 3 is 21. Moving your decimal 3 places. 1, 2, 3. And that's all you've got to do. Plus do your fraction.
Oh.
But I mean, you know that 237 times 9 is 2,133 over 1,000
Equals
equals.
0.1.
Well, I don't like to do it either, but we all forced to do things we don't like to do. Okay.
Yes.
So then it's saying solve using the standard algorithm, which, again, don't worry about doing the word form. Just write it with the decimals in there. Show you're thinking about the units of your product. The first one is shown for you. For me, just work it. Just work it. That's all I'm asking.
What about the bar?
I want to just, I would like to get to the word problems. Because a lot of times we never get to the word problems. You guys know how to work these. I really want to get to the word problems. We never get to the word problems.
Those are the hardest.
Those are the hard parts. I want to get to the word problems. Can we get to the word problems? No, I will believe. No, I'm not looking.
Do you have to keep a zero there?
No, it's at the end. No.
So then you just do
7.5 times 3.5, yes. 7 and 5 tenths times 3 and 5 tenths, yes.
That one makes it so much easier.
He asked if we have to keep this 0 here. No. You can just do that. That 0 at the very end has no value. Only when it's in between numbers do you have to keep it. That 0 has no value. Okay. Carolyn buys 1 2/10 pounds of chicken breast. If each pound of chicken costs $3.70, how much will she pay for the chicken? This is a real world problem. This happens every day. You go to the store, you buy chicken. If 1 pound costs $3.70 and you buy 1 2/10 of a pound, how much does it cost? This is every day. You go to the store and you're like, my gosh, I'm buying chicken. Why is it $8? This is why. My gosh, I'm buying a steak. Why is the steak $15? This is why. Because 1 pound, food's expensive, it adds up. Because if 1 pound is this and you're buying 4 pounds of it, this is why. See if you can figure out how much 1 2/10 of the chicken is.
Oh.
1 pound is that, $3.70. You're buying 1 2/10 of it. It's very similar to what we just did up here. No, did we divide anything?
No.
Are we dividing decimals?
No.
Why would you divide? Have I taught you to divide decimals?
No.
Why would you divide? A decimal on the outside and a decimal on the inside? No, then why would you start doing it today? Have I taught you to do it today?
No.
Then why would you do it today?
I don't know.
Have I taught you to do it today?
No. Yes. Stop playing with it. I'm not playing with it.
It would be at least how much? It would be at least
$3.
$3 because she's getting 1 pound. If it's $3, I know. It's at least $3.70 because she's getting 1 pound. But she's getting a little bit more. So is it going to be more than $3.70? Yeah. $3.70 times 1 2/10. I did not line up my decimals because when you're multiplying, you don't.
I did that last time.
2 times 0, 0, 14, 7.
I got 44.
Add a row, add a 0, 0, 7, 3, 0, 4, 14, 4. Okay, now that looks really huge. You're going like, oh my gosh, 444,000.
I got that.
What?
I got that.
1, 2, and 3 decimal places in. 1, 2, 3. $4.44 for the chicken. Because that's I cannot hear Adley. Sit down in that chair. Hi.
I got 4, 4. At the end, like when I was done multiplying and adding them all, I got 444. I didn't get 4,440.
Did you take the 0 off? That's why.
And I was doing them like that.
No.
And then I saw you right there.
Because I kept the 0. If you didn't, then it shifted it over by a place value. Because then you had 3 and 7/10 times 1 and 2/10. I had that extra 0. So I had that extra place value. I had 2 numbers behind the decimal. You only had 1. Does that make sense? Alright. Mine was kicked over by 1 extra number. A kitchen measures, another real world problem. A kitchen measures 3 7/75 meters by 4 2 meters. Ooh, area. Do you know what area is?
Yes.
Length times width.
Equals something else.
So, area. Wow, if you guys ever want to do some home remodeling, you do need to know area. I have used area because I'm very handy with a tool, believe it or not. I can do tile work. I have retiled the bathroom and the kitchen counter.
Good job.
I can install a toilet. Mr. Strickland can't.
All that stuff.
But he knows.
Toilet.
He makes toilet paper and I can install toilets.
Carson.
So, what is the area of the kitchen? Find the area of the kitchen.
Okay.
I
got it.
Like the area of 1 times width. That's how you find it.
Remember, you do not have to line up your decimals. Don't try. That would be 10. That would be 15. That would be 7. I'm going 1, 2, 3. I'm making a note. Add a row, add a 0. So that I don't get my zeros mixed up from my 20. So this is 28, that makes it 30. This is 15. 0, 5, 7, 15. That's a huge number! Oh my gosh, the area is humongous!
No.
Move your decimal 3 spots.
1, 2, 3.
And then you can just take that
15 and 7/500 square meters.
Can you just write meters?
Well, actually, when you have meters times meters, it's square meters.
Because it's
It's not 2 meters. If you ever, hear about, this is, more than you actually need to know, but, you'll hear, a house and they'll talk about square feet.
Oh yeah.
It's because it's feet times feet. They're talking about
Oh yeah.
the length times
Square.
they're talking about what the length times the width. It's feet times feet. So this is meters times meters. So it's a unit times a unit. So it's meters, it's square meters.
Yeah. What if you have like two different units?
You don't. You have to put them in the same unit. So I can't put like cups times pints. You have to put them in the same units. So if I did like feet and inches, I would have to put the feet in inches or the inches in feet. Or I would have to add them together and say it's this many feet and this many inches. So like these tiles, each tile tends to be a 1 square foot. Because a foot this way and a foot this way is 1 square foot. Okay? And like this entire room, I would take this measurement here times this measurement here, and I could say that it's, I don't know how big it is, I'm guessing like, I don't know, 200 square feet, because it's this times that. And they take the units and squares. So anyway, you take the unit, when you multiply it together, it's not really that important, but you'll hear it a lot. And they just take it and they put that little exponent 2 over it.
Okay.
Hello!
It's like 10
It'd be 100 square feet. I can barely hear you because you started mumbling and you started talking really soft. So, the area of the living room is 1 1/2 times that of the kitchen. Find the total area of the living room and the kitchen. So I was just writing 1 1/2 because I didn't want to forget. So I need to have 1 1/2 times that of the kitchen. So this would need to be times this. So this needs to be a decimal. So 1 1/2. So what can this look like as a decimal?
5.
Oh, 1.5 because
Why is it a 5?
you do powers of 10.
Oh.
5 is half of
10.
10.
Well, how do you know if it's 5 tenths though?
Because if we're doing powers of 10, 5 tenths.
Oh. It's half. It's 5.
So, can you find the total area? Every time you see 0.5 of anything at any time you see 0.5, it's half. Anytime you see 0.5, it means a half. Yeah, on your shoes, like Nikes and stuff, they'll say like a 6.5, 7.5, 8.5, it means 8.5.
Oh.
You need 3 minutes.
Man, you're doing this.
Okay. Because sometimes they'll do a fraction, but sometimes they will do a decimal. Thank you for pointing that out. I totally forgot. So, what can you do with this information?
You can multiply.
This times
that.
this. Which one goes on top?
The biggest number.
Biggest number. You can't really do it by putting the small one on top.
Remember that keep being confused.
25, 35, 37, 25, 28, 5 and 7, And then cross those out so I don't use them again. Add a row, add a 0. And now I'm multiplying 1. So 5, 7, 5, 1.
What?
Let me extend the page. There we go.
Yes.
5, 12, 16, 13, 2. 7 plus 5 is 12, plus 1 is 13.
That's 23,000.
What?
23,605,000.
And then we have 1, 2, and 1 is 3. 1, 2, 3.
Oh, I got that.
Like, I remember if I put 2 above it, or if it's under, I just like, nope.
Bless you.
Oh, yeah.
I can't get back there. Did I hear you? Stop. That's Tania's job. I was asking if it was back.